centrifugal pumps. Okay, so we discuss type of centrifugal pumps and what are the applications. Okay, then characteristic curves. About characteristic curves, how efficiency vary in centrifugal pumps and head versus flow rate. These things we discuss. And okay, here some equations. We already discussed this part. You can calculate suction head using this equation, then discharge head. You can use this equation, and total supply heads by the pump you can get using HT equal HP plus HA. Okay, HP mean effective pump head. HL mean losses in pumps. Okay, then pump efficiency you can calculate using P out divided by P in. P out output power you can calculate P out using this equation. Okay, H rho G Q. Then what is the net positive section head? Is a very critical thing in centrifugal pumps. Okay. Then you can identify characteristic of centrifugal pump using this net positive section head. Its short name is NPSH. Okay. This one indicates how close the fluid in the suction pipe is to vaporizing, which can impact pump performance and prevent cavitation. Okay. Next, the minimum value of absolute pressure that should be maintained at the inlet of the pump in order to prevent cavitation. Okay, then can impact pump performance and prevent cavitations. Then here you can see a breakdown formula for this. NPSHA. NPSHA mean available net positive section head. Okay, available net positive section head you can calculate P absolute minus P vapor divided by rho G. Unit is meter. Okay, then P absolute mean absolute pressure at the inlet flange. Okay, you need to use Pascal to measure this pressure, absolute pressure. Okay, P vapor mean the vapor pressure of the fluid at the present temperature in pascals. Okay, then rho mean density of the fluid. G mean the acceleration due to gravity. Okay, gravitational action, gravity acceleration. This absolute this absolute pressure then in an inlet flange. Okay, this is the pressure exerted by the fluid as it enters the pump. It includes atmospheric pressure plus any additional pressure from the pump's suction system. Okay, this suction side. Then vapor pressure is uh, pressure at which the fluid will being to vaporize at a given temperature. Okay. Then important of this case, maintaining the suction pressure above this vapor pressure to prevent cavitation in our impeller. Okay. Here you can see some cavitations in this impeller, in this area and here. Okay. Then impeller blades are damaged. Okay. These are cavitations. Then system head you can calculate using this equation. Okay, when you are going to pump water from a pump to a top tank. Okay, you can see this type of system. Then this system head mean this head. Okay, then a system head you can calculate using this equation. Z mean Z1 minus, sorry, Z2 minus Z1. This Z mean Z2 minus Z1. What is this part? You know about this part and this part. Can you explain about this part? This part we need to add due to what? Who can explain about this part? Can you explain about the this part and this part? Why need to calculate this 4F LV square divided by D to G? What is the reason using this part and this part? Why we need to add this part? Can you share using chat? I think you can hear my voice. Can you hear my voice? Is it clear? I'm asking about why we need to add this equation part to this total system load calculation. ඇයි අපි මේ පාර්ට් දෙක ඇඩ් කරන්නේ මේකට? මොකක්ද හේතුව? ඔව් මෙතන ලියලා තියෙනවානේ. We need to add these two parts. First one due to friction losses. Okay. Second one we need to add due to component losses. We already know about it. Okay. Then finally you can calculate static static head, system head. Sorry, system head. Okay. Then according to system head, you can identify pump requirement to your system. හරිද? එතකොට මේ total head එක calculate කරාම ඔයාලට එනවා මේ system head කියන එකෙන් total system load එක. එතකොට මේකට අනුව ඔයාලට කියන්න පුළුවන් pump requirement එක. මේ system එකට මෙන්න මේ විදිහේ head එක තියෙන pump එකක් ඕනේ ඔයාලට. හරි? Using this equation you can identify pump requirement. මේක එන්නේ friction losses එකකින් හින්දා මේක ඔයාගේ fittings වල තියෙන loss එකකින් හින්දා අපි මේක calculate කරානේ අපි ගණන් කරා මේකෙන් නේ. We did some examples regarding friction losses and component losses. Okay, equipment losses in pipelines. Both these things we need to add to our total system head. Okay, then according to system head you can calculate your pump requirement. Okay, so here you can identify the system head equation. Okay, here is at plus kq square. Okay, you can convert this v square divided by d2g, this total part, into flow rate equation. You using q equal av, you can convert this v value to q values. After you will receive this type of equation. Okay, then I will explain how this equation, how to convert to this equation. I will explain using example. Okay, so don't worry. Then you will receive this type of simple equation to this total system load, system head. Okay, then here this line indicate total system head. Okay, then you can draw system requirement here like this. Okay, then this graph given by pump supply. Okay, efficiency curve graph and head. This graph, this load characteristic graph given by pump supply. Then we need to draw this purple color one on the graph. Okay, then after that you can identify this crossing area. Okay, according to this crossing area we can identify operating point in our pump. Okay, then according to this one we can select pump head identify. You can identify according to this point pump head and flow rate. Okay, from this point you can identify pump head and flow rate. එතකොට මේ curve එක pump supply දෙනවා. හරි, efficiency curves දෙනවා. මෙන්න මෙයාගේ pump supply pump එක manufacture කරන එක්කෙනා මෙන්න මේ graph එක දෙනවා. හරි, ඔයාලට තියෙන්නේ මේ calculation එක දාලා ඒකෙන් එනවනේ මේ වගේ equation එක. මේ equation එකට graph එක අඳින්න. graph එක ඇඳුනහම මේ point එක cross වෙනවානේ graph එකත් එක්ක. cross වෙනකොට ඔයාලට හොයාගන්න පුළුවන් ඒකේ flow rate එකයි head එක. හරි. ඒ head එකයි flow rate එකයි match වෙන impeller එක හරි එහෙම තමයි ඔයා select කරගන්න ඕනේ pump එක. හරි. Okay, then in this case, you can identify flow controlling process done by using a damper. Okay, when you are use the damper to control flow, then graph will shift to like this, shift to this position. Okay, when the damper is partially closed, then this graph will shift to this position. It means flow rate will be reduced. Okay, here you can identify flow rate will be reduced. When you use variable speed drive to control flow, then you can identify uh, this type of point, operating point. In this case also, flow rate is reduced. Okay. Then here N1 mean speed of the fluid. Okay. Then it will reduce. Then graph will like this. Okay. Then you can draw your characteristic curve like this. Total head system. Then you can get this point. According to this point, you can identify flow rate and head. Okay. These are two controlling methods, flow controlling methods, damper, using damper and variable speed drive. Okay, VSD mean variable speed drive. Okay, then okay, we will try to do some example. I will share one PDF using chat. I will share one PDF through chat. Please download and try to do this one. Okay. Hmm. If you have any questions, you can ask. Okay, I already shared one question regarding this pump, centrifugal pump. Okay, this one. Please try this one. First one is show that the load curve of a piping system can be represented by the following relations. You need to derive this equation. If you want a lecture note, I will share it now. ඔයාලට ඩවුන්ලෝඩ් කරගන්න පුළුවන් නේද? chat එකේ පෙන්නනවා නේද මේ මම PDF එකේ උප එක? Okay. In first pass, you need to derive this equation. Okay, H system equal Z plus KQ square. You can use total head equation, total system head equation to derive this equation. You can use. Please try this A part A. Then after completing yourself, I will explain. After complete by yourself, I will explain. Can you able to get this one? If you did this part, please share with the chat. Okay. කවුරුහරි කරා නම් දාන්න මේ chat එකේ. කරාද? This first part. Okay, I will share answer for first part. Okay, here you can see answer for first one. Then here you can identify small interaction part regarding questions. Then in this question, we are going to learn how to choose a centrifugal pump for a given application. Okay, then you need to draw a small sketch like this. Okay. Then after that, you can write uh, system head equation like this. Okay. According to this that equation, we can write this one. Head developed by the pump equal static head. Static head mean Z. Z2 minus Z1. And losses in suction and discharge side. Both side we need to consider. Okay. Losses in suction and discharge side. Okay. Then you can write friction losses, suction and discharge side. Then component losses. Okay. This equation we can write according to Darcy equation, the Darcy formulas. Okay. After that, you can apply Q equal AV. Okay. Using Q equal AV, you can find P value. V equal Q divided by A. Okay. Then you can use this Q equal AV to this equation. Okay. Then you can remove this V part using this V equal Q divided by A. Then you will receive this equation. This one. You can get this one. Okay. Total system head equal Z2 minus Z1 for F. L divided by F mean friction coefficient divided by D 2G Q square divided by A square. Okay. Then you can take Q, you can write Q as like this, Q square. You can get out to outside. Okay. Then Q divided by A, you can apply it to component losses equation like this. Then finally you can write again, you can rearrange this equation like this. Okay. Then this part, this is a constant friction coefficient. This one is L length is a constant. D is the diameter constant. G gravitational acceleration also constant. A cross sectional area also constant. In this case also K constant value, G constant value, A constant value. Due to this reason, we can get this total part as a constant. Okay. Then you can write this equation. Okay, then these are constant. Due to these constant values, we can say total part should be constant. Okay. You need to write assumptions like this. Note that K is constant. We have assumed that uh, friction factor is constant. Okay, friction factor is constant. We calculate F value at required flow rate. Our actual flow rate also will be closer to expected flow rate. Hence, F will be changed only by little. So taking F constant is the reasonable assumptions. Then according to this equation like equation get like a parabolic shape. Okay, this curve has a parabolic shape. Okay, then you can draw this type of uh, graph to this parabolic equation. Okay, according to this equation, you can draw H versus Q. H mean this system head H. Okay, then Q mean this flow rate. You will receive this type of graph. Then this bump curve will give by supplier. Okay, pump manufacturer gives the characteristics curve. Okay, and this type of curve will given by supplier. Then okay, then you can draw both graph in a one graph. Okay, then this graph according to pump supplier, and this will take according to our calculation. Okay, using this equation, then you will receive this operating point. According to this operating point, you can calculate pump head and flow rate. Okay, then both curves explain the same things. Therefore, head developed by the pump and the both curves are correct. However, the only point which satisfies system curve equation and manufacturer curve is the intersection point marked above. So that point will be the operating point of the pump when installed in the pipeline. Then the main aim of the pump selection is to identify the operating point. Okay. Then according to operating point, we can select our pump. Okay. According to operating points, we can identify flow rates, head developed by the pump. Okay. And also we can calculate efficiency of the pump and operating point power consumptions. Okay. Then this is the equations. This is the equation we need to derive. You can use this equation to derive this one. This one. Okay. Total system head equation. I will share this answer. Then next thing is a pumping system is designed to supply aviation fuel. to small aircraft at a rate of 27 cubic meter per hour through 8 centimeter diameter. Then pipe length is 110 meter. The total static head is 3 meter and system incorporates a gate valve for flow controlling. In this system consists with the gate valve. The Darcy friction factor for the flow through the pipe could be considered as a constant at 0.006. F becomes 0.006, and the sum of the coefficient of fluid resistance. Sum of the coefficient of fluid resistance K factors of pipe fittings. Okay, it's mean K factors in components in this system. Then total value is 14.1. Okay, and this part consider without gate valve. Then K factor for a fully open gate valve is 0.2. Okay. Then identify suitable. First one is identify a suitable size for the impeller diameter using given pump performance curve. In appendix A, here you can identify given pump characteristic curves. Okay, this will this given by pump supplier. Okay, pump manufacturer. Then given pump performance curve in appendix A to be used in the application. Justify your answer. Then second one is determine the operating point of the pump and corresponding efficiency when it is installed in a system with the gate valve at its fully open position. Okay. Then third one is the required flow rate is obtained by controlling the gate valve position. Determine the position of the gate valve to be set. Then calculate the corresponding input power requirement for pumping. Suggest another method to obtain the required flow rate but with a lesser power requirement. In this case, they control their flow rate using a gate valve. Okay, it's like a damper. We need to design this system considering flow rate is 27 cubic meter per hour through 8 centimeter diameter pipe. Okay. System requirement is 27 cubic meter per hour. Here you can see an answer for this one. Okay, you can draw a simple diagram like this. Then here fuel tank. You need to bring this fuel to aircraft tank, aircraft fuel tank. Okay, here you can see storage tank, fuel storage tank. Then you can draw your system like this: pipeline and pump, and gate value you can identify here, and this area discharge pipeline. Okay, this is the pump. Then you can note down given details. Diameter is pipe diameter is 0.08 meter. Okay, 8 centimeter. Length is 110 dz. Dz means Z2 minus Z1. Then the total static head, they already given static head. Okay, Z2 minus Z1 value. Okay, then dz is 3 meter. Then friction coefficient, Darcy friction factor 0.006 given, and they given component all component coefficients, sum of coefficient of fluid resistance uh, of pipe fittings, all k values. Okay, sum of k values given. Then the k value given for fully open gate tab. Okay, then you already know about the equation, system head equation. You can write it like this. Okay, this one. System head equation equal Z2 minus Z1. Okay. Then you can write like this. Okay, you can get this equation because they given Q value. Okay, 27. We need to design according to Q value, a flow rate value. Then we need to consider this equation or this one. Okay, both are same equation. You can use this equation, and according to this equation, you can write down Z2 minus Z1 value is 3. Okay, then for F, for here, F value 0.006. Okay, friction factor, multiply by L over D. L over D, length of the pipe 110 divided by D, diameter of the pipe 0.08, and multiply by 1 over 2G A square. Okay, then 1, 2, G we can get as a 9.81. Okay, then A, you need to calculate A value using 5R square. Okay, D given. Using 5R square, you can calculate cross section of the pipeline. Likewise, you can add this component losses like this. Okay, after that you will receive this equation. Its system, okay, total system head equal 3 plus 95618 Q square. Okay, Then now we have the system curve on top of the pump curve. Then according to this equation, okay, this equation like this one, okay, delta Z plus KQ square. It will take parabolic shape. Okay, got that point? Then you can you can draw this graph H versus Q graph top of the this given graph by a manufacturer. Okay, here red color one, this one we can draw according to this equation. Okay, how can we draw this one? They given axis values. Okay, and then first one is 0, then you can put 0 here, Q as a 0, you can take Q as a 0, then you can put 0 to this equation, then you will receive H as a 3. Okay, then second value is first value 0. Okay, now you can draw first point here. Okay, like this here, it should be here. Then according to these values, then second point is 5. Okay, please consider when you are going to do your calculation, you need to consider these units, cubic meter per hour. Okay, then you can get 5 value. You need to convert into cubic meter per second, because we uh, get these values as a meter per cubic meter per second. This Q value we consider as a cubic meter per second. We need to convert cubic meter per second, and you can add this 5 divided by 3600 to this equation. Then after that you will receive H as this value 3.18 meter. Got that point? Can you tell me can you give me some feedback about your understanding? Okay, then next value is, then you can draw another point here. According to this 5 point, value is 3.18. 3.18, very close value to this one you can draw here. Okay, then next point is 10. Okay, this 10 point, 10 you can put Q as a 10, but we need to convert into cubic meter per second. Given value is cubic meter per hour. Okay, due to this reason we need to convert cubic meter per second. Then after that you can put this value into our equation. Okay, then you will receive this one. Head as a 3.74. Okay, 3.74 like this. Okay, Then you can find another point here. Then again you can put 15. 15, you need to convert into cubic meter per second. Then after that you need to add this equation. You will receive this 4.66. Okay. Then 4 here, 4.5 here, 4.6 like this. Okay. Then next value is 20. We need to convert into a cubic meter per second. Then after that, using equation, you will receive 5.95. You can go next point. Value is 5.95. It is very close value to 6. Okay, like this. Okay. And then finally you can, using all values, finally you can draw your graph. 20, 30 here, 35. Okay, according to these points, you can draw your curve. Okay, පුළුවන් ද මේක ගන්න ගන්න? ඒතර මම එක්සෑම් එකේ දෙනවා මේක අඳින්න. මේ ඔයාලා කතා කරන්නේ නැත්නම් තේරෙන්නේ නැද්ද නැත්නම් මොකක්ද අවුල? මේක ලොකු දෙයක් නෙමෙයි පම්ප් එකකින් මොනවා හරි දැන් මේක නම් ෆුවෙල් එක ගහන්න. වතුර ගහද්දිත් මේකම තමයි. ඒතර මේ ඉක්වේෂන් එක මතක තියාගෙන ඒකට අනුව හදාගෙන යන්න තියෙනවා. ඒතර ඔයාලා කර්ව් එක ඇඳ ගන්න ඕනේ ඔයාලට රික්වයර්මන්ට් එකනේ කර්ව් එක. හරි? කර්ව් එක අඳින්න තියෙන්නේ එයා දීලා තියෙන කර්ව් එක තියෙනවනේ ඒකේ දීලා තියෙන ඇක්සිස් වැලියු එකයි හෙඩ් වැලියු එකයි බලලා ඒවට වැලියුස් දාලා අඳින්න තියෙන්නේ. ඊට පස්සේ ඔයාලට මෙහෙම පොයින්ට් එකේ ආ කරගෙන ගියාම ඔයාලට කර්ව් එක එනවා. After connecting all points, you will receive this curve. You need to draw an exact graph for this process. Okay. So method එක හරිද? curve එක අඳිනවා. මාව ඇහෙනවද ඔයාලට? Can you hear? Okay, can you understand this criteria, these methods? ඔයාලට තේරුම් ගන්න පුළුවන්ද මේ ටික? If you are unable to understand regarding this, we can't continue this part. Okay, anyway, in this case, they given six curves here. You can see six curves. Okay, this one, first one, this one, second one, third one, fourth one, fifth one, sixth one. Okay, you can identify first curve here, second curve here, third curve here, fourth one, fifth one, sixth one. Okay, these curves indicate impeller sizes. Okay, impeller sizes you can identify using this point. Okay, this 7.5 inch mean one impeller size. Another impeller size is 7.0 inch. Another one is 6.5 inch. Next one 6. Then another impeller diameter is 5.5. Another diameter is 5.0. Likewise, you can identify impeller diameters using uh, given diagram. Okay. Then this pump comes with six impellers with different diameters. Okay, these are different diameters, and you can identify six impellers. And user has to choose the best one of the application. Best pump will depend on how you are going to operate the pump. Then we need to design the system according to this 27 cubic meter per hour flow rate. Okay, we expect a flow rate of 27 cubic meter per hour. Then based on our curve drawn on only 7 and 75 can be delivered flow rate more than 27 cubic meter per hour. According to your graph, okay, you need to identify 27 cubic meter per hour point. Here you can see 25, 26, 27, this line. Okay, this I can't draw a vertical line. Accurate vertical line I can't draw. So here you can see this our curve crossing in this point. Okay, after this area you can identify 7 impeller cross this point and 7.5 inch diameter impeller cross on this point. These are operating points. When you use 75 impeller, you will receive operating point as this point. When you use 7 impeller, 7-inch diameter impeller, you will receive operating point as this point. Okay. So operating point දෙක තමයි මේක. We cannot get this operating point because flow rate should be 27 cubic meter per hour. Okay. Then according to this phenomena, you need to select 7-inch diameter impeller or 7.5 impeller diameter. Okay. Then a flow rate with all other impellers are lower than expected. Then so we expected value over 27 cubic meter per hour. So we cannot use them for this application. Okay. Then we can use these both values. Okay, then ahead you can calculate according to this point. Then efficiency 75, 75 for 7-inch one, this one, and for this one, here I think 76 this point. Okay, yeah, 76. These are efficiency curves. Okay, these are efficiency curve. You can identify efficiency here 40, 50, 60, 70, 75, 76 here, and 77, 75, 70, 60, 50, like this. These are given efficiency. According to that one, you can identify head efficiency and impeller requirement. Okay. Then a power requirement you can calculate using this equation. You know about the efficiency. Okay. 75%, 76%, likewise. And other values you already known. Then we can identify best impeller. Okay. Then if it's okay to have slightly a higher flow rate than required, then what is the best impeller for this case? Find the answer. Um, then flow rate is in our system flow rate should be 27 cubic meter per hour. Then we need to close the gate valve partially and reduce the flow rate required value. Then you can consider one impeller size. If you want to consider 7-inch one, you can consider. If you want to get 7.5 impeller, you can get. Okay. In this case, take as a 7.5 impeller. Okay, then here the gate valve, when the gate valve closes, it loss the coefficient increases. As a result, K value increases and the system curve moves upward as shown in figure next slide. Here the gate valve is set to get 27 cubic meter per hour flow with 2.5-inch impeller. So we know that the new system curve should be go through the point. Then again, you need to draw system curves. Okay, then okay, this is not an assignment. So I will give another assignment in next week. Okay, about the pump curves. So this is the answer for this one. Okay, then first one we did, then determine the operating point of pump and corresponding efficiency when it install the system with the gate valve is fully open. Question already done. These are efficiencies. Okay. Then the required flow rate is obtained by controlling valve position. Determine the position of the gate valve to be set. Then you need to calculate this. You need to identify this K value. Okay. Then in this case, we can't consider this gate valve K value as a 0.02. We can't consider as a 0.2. Okay. Then using equation, using total head equation, efficiency equation, and these things, you need to calculate this new K value for this gate valve. Okay. According to this received new K value, you can identify this gate valve position. It will sometime partially close. Okay. Likewise, you can identify gate valve position. Okay. Then calculate the corresponding input power requirement for pumping. You can calculate using this equation. Input power efficiency equal P out divided by P in. Okay. Then calculate the corresponding input power requirement for pumping. Then using this one, you can identify efficiency P out divided by efficiency. You will receive P in. Okay. After calculating this P value, you will receive P in value, input power value. Okay. Then suggest another method to obtain the required flow rate but with a lesser power requirement. What is the another suggestions? Suggestions for this operation. In this case, controlling process done by using a gate valve, using a gate valve. Okay. But we can use variable speed drive to operate this system. Okay, we can control flow rate using variable speed drive. Okay. Okay, then okay, I will give another question regarding this, and you can try at home. I will share using chat. Please try this one at home. Okay, I will try to discuss these questions in another day. Please try to do this one at home, and I will share answer for this first one. Okay, please try this tutorial number 2 at home. Please try to get this k value at home. Okay, this third part 3. Please try at home. You can get this one k equal something value. Then you will receive some value to k. Okay, please try this one at home, and I already did this part, this one, and this one you can calculate at home. Okay, got that point. Is it okay? Can you tell me if you want another clarifications? You can tell me if you have any clarifications regarding this. If you require any clarifications. මේ ඔයාලට දැන් එවපු ලෙක්චර් නෝට් දෙක ආවද? නෙමෙයි මේ ටියුටෝරියල් දෙක ආවද? මම කවින්දුට යවලා තියෙන්නේ. Okay, you can download now. Okay, using chat you can download answer for given. We already discussed one, and you can try this tutorial number 2 at home. Try and try to get answer for this. Yes, Randika, you can ask. Anuruddhika, you can ask. Anuruddhika is raising hand.
Recording stopped.
Okay, this one is the question number 2. A pump system is designed in the household to pump water from well to water tank. The total static head given 5 meter. The system is having 8 centimeter diameter, 120 meter length pipeline. Pipe system consists of pipes, elbow, coupling, and their quantity in the pipes are given a table number 1. Okay. Then quantity given like this for suction side. Then compound losses factors of each compounds are given in table number 2. Here you can see K factors. Assume the RC friction factor as 0.05, F as a 0.05. You can get F as a 0.05, density as a 1000. Water density is 1000. Then obtain the equation of the system curve. You need to get this H equal Q square something. Okay. Using total head equation, then plot the characteristic curve HQ head versus flow rate curve using the data given in table number 3 and plot the system curve in the same chart. Find the operating point of the system. Okay. You can draw system curve using this data. Okay, you need to draw two graphs, and finally you can get operating point. Okay, this one is very easy example. Please try this one at home, and next day I will discuss regarding this. Is it possible? Can you try this one at home? මේකවත් පුළුවන්ද කරන්න? Anyway, I will collect this one in next day. Okay, I will collect. You need to do this one at home. I will collect this one. Okay. Please try by yourself. Next day, I will give assignment regarding this pump, centrifugal pumps, and also it will take home assignment. Okay, probably it will take home assignment. So we need to start another part in this lecture. So I will share presentation.
Recording stopped. Recording in progress.
Okay, sometimes this Zoom connection is disconnected. I think you can hear my voice. Okay, I will share. Okay, in this part, we will discuss about hydraulic system. Okay, this is a very important system in fluid mechanics. Okay, then in this part, we will try to discuss what are the applications and also how to design this fluid mechanics system using Fluid Sim software. Okay, I will explain how to draw our fluid mechanics systems. Okay, and how to design these things. We will try to discuss under this topic. Can you hear my voice? Am I audible? Okay. Okay, what is the hydraulic system? What are the things you know about the hydraulic? Hydraulic is a fluid. Okay. Can you give us some suggestions about the, can you give some idea about the hydraulic oil? Then as a definition, power hydraulics or fluid power deal with generation, control, and transmission of power using pressurized fluid. In this case, these are some application, generation, control, and transmissions. Okay, power transmissions. Transmission mean power transmission. Okay, some hydraulic coils and yeah, basically we can use hydraulic oils for this purpose. Okay. Then this oil is used for this hydraulic oil is to used to hydraulic oil is used to transfer power uh, within the hydraulic system. Okay. Then allowing for the operation of machinery and equipments. Then and also we can focus when you are when we are focusing lubrication process in hydraulic oil, provides necessary lubrication to moving parts within the hydraulic system, reducing friction and wear in the components. Okay. Then and also hydraulic oil helps reduce heat generation in our system. Okay, in our hydraulic machinery. Then including hydraulics, which involves liquid, and pneumatic, which involves gas. Then in this case, in a hydraulic system, we can categorize like this: liquid as a hydraulic oil. Pneumatic mean air. Okay, air, and some gases we can use for the hydraulic system. Then under this liquid part, we basically we can consider oil as a hydraulic oil. It's a high viscosity oil. Okay. Uh, then we can maintain this oil under various temperature range. Okay. Then hydraulic oil also have a good stability to resist breakdown, thermal stabilities. Okay, hydraulic oil have good thermal stability to stability in then here you can identify some applications. Using hydraulic system. Okay, then industrial applications, you can identify plastic machine. Plastic machines mean injection molding machine. Okay, using this machine, you can create molds and some. You can see this type of machine in plastic box manufacturing industry, and pen manufacturing industry. Likewise, industry they use injection molding machine. Okay, and also this hydraulic system used in presses and heavy machineries. Heavy machineries mean mm, some hydraulic system used in what are the example for heavy machineries in industry? Mainly use hydraulic oil and pneumatic. Okay. Uh, some gases also use for these machineries. Then what are the application for machine? What are example for heavy machineries in industry? Then we can take machineries, steel bending machines and robot arms, some robot arms working using hydraulic systems. Okay, robot arm used for material handling purpose and some lifting device. Okay, these are heavy machineries. Some pressing machines. Okay, press gun machines, robot arms සමහර ඒවා තියෙනවා. තව heavy machines මොනවද තව තියෙනවද දන්නේ? steel bend කරන ඒවා, තලන ඒවා නේ. ඒ ඔක්කොම heavy machinery තමයි වැටෙන්නේ. Then machine tools mean we can consider some milling machines, lathe machines, they use hydraulics. Okay. In mobile hydraulics, mobile hydraulic systems, we can see excavators, cranes, then material lifting and pick and place process. We can use these cranes and constructional and agricultural machineries we can see. Okay, these are few applications for mobile hydraulics. In this case, basically, we can identify power transmission process done by pressurized fluid. Okay, power trans in this fluid hydraulic fluid system, in this hydraulic system, a power transmission process done by using pressurized fluid. Okay, then these are another applications, hydraulic in steelworks, civil engineering, generating stations, log gates, dams. These are used in power station. Okay, then mining machineries, turbines. Turbine also working due to this fluid. Okay, working turbine also working using fluid, water. Then nuclear power plants, bridge operating equipments. Then hydraulic in special technical applications, telescope and antenna operations, landing gear and radar control aircrafts. Okay, then here you can identify some mobile applications. Okay, then in the first figure you can identify underground mining machineries. So these machineries working using hydraulic oil. Okay, in this case have some actuators, piston, some hydraulic motors. Okay, and according to pistons and these actuators, this will operate. Okay, excavator and equipments, construction equipments. Okay, these are applications: motor grader, dumper, loader. Likewise, these all are applied applications. Then here you can identify some advantages using a hydraulic system. Okay. Then a hydraulic system we can categorize as a fluid or we can categorize fluid and pneumatic. Okay, pneumatic mean air. Sometimes we can use air as a hydraulic, and also we can use hydraulic oil as a liquid. Okay, sometime we can use some gases as a pneumatic. Okay, basically pneumatic mean air. Okay, basically we can use air. These are some advantages of the fluid power system. Then under this part, you can identify simple and accurate control. Okay, when you use fluid to operate machineries and other equipments, then it is very simple to control and very accurate. Okay, then you can apply actual force using these machines and using this fluid. Okay, you can get actual required speed, and you can get actual positioning using this fluid power. Okay, then it will give accurate requirement. Then multiplication of forces. Then multiplication of forces mean these systems can amplify input force to produce much larger output forces. Okay, we can get large output force using these fluid systems. When you can take as example, you can consider excavator. Okay, using small force, uh, you can take large you can handle large amount of mass. Okay, you can lift a large amount of mass using excavator. You can handle using a small lever. Okay, you will give a small force to a lever, then output force is very large. Okay, this is a very helpful applications in heavy machinery. We can see this multiplication of forces. Then instantly reversible motion mean a fluid power system can quickly change the direction of motion. Okay, if you want to move piston, if we want to move a fixed piston to a forward direction, then suddenly you can move again it to a backward direction. Okay, then quickly change the direction of motion. Then it will help to very quick motion in our machineries. Okay, we can design our machineries according to this method. Okay, stepless change of speed, torque, or force. Then step less change of speed mean fluid power system provide smooth and continuous variation in speed, torque, and force. Okay, then allowing adjustment during operations. Okay, then capable of providing constant force or torque regardless of speed changes. This case, they maintain consistent output force or torque even when the speed of the actuating mechanisms varies, ensuring a stable performance. Okay, then simple automatic overload protection mean simple automatic overload protection mean safety mechanism protect the system uh, from overload without needing complex control system. As example, you can build your system with the pressure relief valves. Okay, then these are the advantages. Then next one is high force or torque with compact size. Then fluid power systems can generate significant force and torque from a relatively small. Okay, then we can consider a small machine, lightweight components. Okay, then we no need to use a large space area to install these machines, fluid machines. Okay, then we can install in a small area. Then a simple operation and maintenance. These systems are generally uh, simply to operate, then straightforward to operate and maintain. Then you can identify some mechanical components, lot of mechanical components in this system. Okay, then fluid system. Then when you are use hydraulic coil or something, then wearing wearing is reduced. Okay, in our machine parts, but maintenance process is required. Okay, maintenance is required for this system, but simple operation is okay. Then under this slide, we can discuss about disadvantages of fluid power system. First one is hydraulic oil are messy. The use of hydraulic oil can lead to uh, spills and leaks, resulting in a messy working environment that require regular cleaning and maintenance. Okay, maintenance is very important under this. We need to consider under this. Okay, when you are going to design a hydraulic machine, you need to consider maintaining process. Okay, because maintenance is very important for this fluid mechanism, fluid machineries. Then regular maintenance cleaning is required for this hydraulic machines, and leakage cannot be eliminated completely. Then leakage cannot be eliminated complete mean sealing technology. Okay. Then some degree of leakage is inevitable in fluid power systems, which can reduce efficiency and uh, increase maintenance needs. Okay, reduce efficiency and increase maintenance need. The hydraulic line can burst. The high pressure hydraulic line bursting. Okay. Uh, then safety risk have some safety risk. Then potentially causing significant damage to equipments and equipment also surrounding area. Okay. Then these are very critical case. Hydraulic line can damage. Okay. May cause fire near oil leakage with hot temperatures. The hydraulic oil are flammable. Okay. Hydraulic oil are flammable. Hydraulic coils are flammable. Then we need to consider these things. Okay, these are the disadvantages. Then due to this flammable oil, then can be fire hazards. Okay, then we need to careful about the hydraulic oils. Okay, sometimes it will be risk using hydraulic oil. Okay, then under this topic, basically we will discuss hydraulic and pneumatic. Okay, and this is a small introduction for hydraulic and pneumatic. Okay. Next day I will discuss these things and pneumatic and hydraulic. Uh, okay, under this part, I will try to explain how to design a system using some software, and here you can see some component in a hydraulic system is cylinder, pumps, okay, motors here. Okay, we can develop this type of system. Okay, here you can identify total hydraulic system. I think this one is a hydraulic, yeah, hydraulic one. Okay, hydraulic and pneumatic, we try to design. Okay, these are actuators, piston. Okay, so okay, I will stop here. Then next day we will discuss about hydraulic and pneumatic. Then what are the specifications in hydraulic system and pneumatic system, we can identify what are the pipelines we need to use, what are the equipments, okay, pressure releasing methods and pumping methods we can discuss in next time. Okay, these are valves. Okay, these things we will discuss in next time. Please try this tutorial number 2 at home. Okay, I will check in next day. Mm, you need to bring your answer. I will collect it. Okay, so thank you for your participation and your support. If you have any question regarding this, you can ask. If you have any issue,
Recording stopped.
okay, you can ask any questions. Please try to download Fluid Sim software. Okay, try to download Fluid Sim software. I will show you what is the software. Please try to download this software. This one I will show you. This one. Using this one, you can design your fluid system. If you want to design hydraulic system, you can design. If you want to design pneumatic system, you can design using this one, Fluid Sim. Okay. I think it is available. You can find. I think it is available in Get Into PC. Download and try to do this one. Okay. You can download using Get Into PC. Free version. Download and try to do a design. Have some YouTube videos you can try to do. You can identify components, everything using this software. Okay. Here in this part, you can identify main components, pumps, actuators, motors, cylinders, everything you can identify. Valves. Okay. Okay. Please try at home your assignment. Sorry, tutorial. Now I will stop this one. Thank you for your support.